sequence we are given, even though in this case we are told that the sequence we are given is arithmetic sequence, and this is a sequence because you can see the terms are separated by a semicolon, but with a series, the terms they are separated by what? By a positive sign or a negative sign. So in some cases, you're going to find a negative sign. So let me emphasize that. So now, for you to confirm that indeed what you are given is arithmetic sequence, you need to take what is called the common difference, of which I've emphasized many times, that the common difference you will obtain by subtracting the first term, the second term of the first term, and in this case it's going to be 2. 3 minus 1 is going to be 2. 5 minus 3 is going to be a 2. Therefore, we have the same number of 2, which simply tells us that the common difference, which is indicated by letter D, is equal to what? It's equal to 2. So I believe all of you can be able to do the first part of the question, which is about to get the common difference, or to prove that indeed what you have is a arithmetic sequence. So we have confirmed that indeed this is arithmetic sequence because the common difference is the same throughout the sequence. Né? That is fine. Now let's answer the question now. So the questions the first question say, determine the 53rd term of the sequence. So how many terms are we given here? We're given 4 terms. Né? So now, after having the dots, or after having unknown terms, we need to get the 53rd term. You can be able to get this by adding a 2 in each term. For example, the next term in this case is going to be 5 plus 2, which is 7, 7 plus 2, which is 9, 11, and so on. But imagine, this sequence requires us to get 53 terms. Do you think it's something which you can be able to do until you reach 53rd term? No, that process is not possible to do with a short period of time. So what you need to do is to use the formula for arithmetic sequence, of which I gave you the formula. So the formula for arithmetic sequence, not a series, a sequence, is given by Tn, which is equal to A plus into n minus 1 multiplied by what? Multiplied by a d. I believe we're all together on that one. Eh? So now let's substitute the information we have and answer the question that is required. That's question number 1 there. So we are looking for the term number 53. Term number 53 is indicated by T sub 53. Of which we're going to obtain by substituting the first term, the number of terms, and then the common difference. So the first term from this sequence is what? Is -1 plus into, and then the n, we know, if we are looking for the 53rd term, it tells us that the number of terms are 53 in this case, -1, multiplied by the common difference we obtained when verifying that the sequence we have is arithmetic. So the common difference is given as what? As 2. So therefore, by doing so, you would have obtained the expression which may lead you to the answer that you require. Can you put this into your calculator and tell me the answer you obtain? What answer do you obtain when you put this into your calculators?
103.
133.
No, 103.
Okay. Yes. So this is the answer we require from the first question. So now let's quickly go to question number 2, of which is what I wanted to focus more on, because we have covered the first part of the question, but the second part is where we are now to deal with what is called arithmetic series. There is a relationship between the series and the sequences. So the first question was about the sequence. Now the second part of the question is about the series. What the question is saying here, we want to determine the sum. Whenever you hear about the word sum, think of a series. The sum of the how many terms? Of the 29 terms of the sequences. So in other words, you will be having 29 terms and then add all the terms we have, all the first 29 terms we have from the segment, and then you would have answered this question. But don't do that manually, otherwise you will not get, some teachers, they might not give you even a single mark. So you will need to use a formula to do that, because already we know that what we are dealing with here is arithmetic sequence which have relationship with arithmetic series. So it's gonna be, this is gonna be converted to arithmetic series by replacing semicolon with positive signs. So it's gonna be -1, 1 plus 3 plus 5, and so on. So that gives you what is called the arithmetic series. Then if we are talking about the arithmetic series, there's just one formula which must clock your mind, which you must remember at all times. So it's given by Sn. S sub n simply stands for the sum of the nth term. For example, let's say we have million terms here. So those million terms, if you want to add them all, you can then be able to use this symbol 2, stands for the summation of all the terms you are going to add, which is equal to n over 2, where n is the number of terms, into 2n plus into n minus 1 multiplied by d. Why did I use the square brackets here? I used the square brackets because inside those brackets we have the what? The small bracket. So it was not going to be neat if I use the small brackets here and then the small brackets again. So if you use the small brackets outside, you can then use the square brackets outside. And then if you have the square bracket, then you can use the curly bracket like that. So you can follow that order just to make your work neat. Now, we are looking for the summation of 29 10. Therefore, it means where you have n, you're going to replace the what? By 29, which will be equal to 29 over 2 into 2. The first term is given, which in this case is -1, plus n is given by 29 minus 1, and then the d is given by what? By 2. Can you put this into your calculator and tell me the answer you obtain?
783.
1183.
No, 7, 8,
Yes.
3.
Okay. Definitely. That's the answer we were looking for. So these are the kind of questions you must expect in exam. All the questions I sent to you on WhatsApp, they are from different previous question papers. So in other words, this simply tells you that when you write an exam, you are going to come across these kind of questions. You must expect to write the same kind of questions we are dealing with here. So we have covered the first question, which is about the arithmetic sequence and the arithmetic series. Let's do the second question together, and then from there, I'll give you a third question to try. So now, or maybe before we go there, if one of you did not understand what we have on the board, just tell me before I wrap, and I will explain that further. Are you all fine with what you have on the board? Okay, so it seems as you are fine. Then let's now go to the second question. I'm going to wrap everything we have there. So the easy way to capture everything we have on the board is just to take a screenshot in your phone, and then you will have everything that we have on the board, other than to write, because the main point is for you to listen and understand what you have. So you can just take a screenshot and you will be having everything we have on the board. Okay, I'm now wrapping. Okay, let's go to question number 2. This question is about arithmetic sequence. We are told that in the arithmetic or in an arithmetic sequence, term number 4 is given by 2x plus 1 and term number 10 is given by 8x minus 2y. The question requires us to determine the first term of the sequence in terms of x and y. So this is what we require to find to determine the first term of the sequence. But that first term must be in terms of what? Of x and y. For example, term 10 is in terms of x and y. Term 4 is in terms of x and y. Therefore, the answer for the first term, it must also be in terms of x and y. We are not expecting that you get an actual value here. So the value you must get, it must be in terms of x and y. I believe you understood what I said just now. So now let's quickly go to answer the question that is required here. So now the question you are going to obtain it by using a smart, you can use the formula, because already we are told that this is arithmetic sequence of which you can find by using the formula Tn, which is equal to a plus into n minus 1 multiplied by what? Multiplied by t. So you can use this kind of information that we have there to determine the first term. So now let's substitute term number 4 and term number 10 into this formula so that we generate two systems of equation, of linear equations. So now let's start with the term number 4. Where you don't understand, don't hesitate to let me know so that I explain this to you, because this is a bit complex because it requires the use of simultaneous equation. So now we have T4. That is our starting point. We want to get term number 4, of which we will obtain by substituting 4 wherever we have n. So here we have n, we're going to substitute 4. But where we have a, we don't know what's the value of a at this point. Therefore, you just leave it as it is. Plus, here you have 4, which you can substitute 4, and you have 4 minus 1, which gives you a 3. A d is not given, so you just write it as it is. And this is equal to the value that is given. The T4 is given as what? As 2x plus what? Plus y. And this you make equation number 1. Let's go to equation number 2. How are you going to get equation number 2? You will obtain equation number 2 by using the information that you are given down there. So now, term number 10, you substitute that information into this formula, you will have a plus, where you have n, you substitute 10. So it's going to be 10 minus 1, which gives you 9d. And that will be equal to, term number 10 is given as what? As 8x minus 2y. And this will be equation number what? Equation number 3. Once you see something like that, what must come into your mind is the simultaneous is simultaneous by elimination or simultaneous by substitution, whichever way you prefer. You are going to get to the answer that we are looking for. Suggest which method do you want me to use to obtain the answer for this question?
By subtraction, elimination.
Okay, let's use elimination to get the answer for that. So now we need to eliminate as a variable with the same coefficient. Which variable have the same coefficient here? Coefficients are these numbers which are before the variables. We have variable a and d. Therefore, the numbers we have here are the coefficients of which you check the variables which have the same coefficients. You can see a have coefficient 1 on equation number 1, and A have coefficient 1 on equation number 2. Therefore, you can eliminate that variable, even though we know that we are looking for the value of that, but we will attend to that at later stage after eliminating the variable and obtain the D. Because if you don't want to eliminate the A, you can eliminate the D. But what do you do if you want to eliminate the D? You first have to make sure that the coefficient of D are what? Are the same. Can any one of you tell me how are we going to make sure that the coefficient of D here and the D there are the same? What can we do to make sure that they have the same coefficients? We can do what? We can multiply equation number 1 by what? By 3 throughout, ne? So let's multiply that and see what we obtain. Equation number 1 multiplied by 3. Let's see what you get when we multiply equation number 1 by 3. So it means any time we have on equation number 1, it will be multiplied by 3. A is going to be multiplied by 3. Therefore, we will have 3A. 3D is multiplied by 3. We are going to have plus what? Plus 9D. 2 multiplied by 3 is going to be 6x. And then there we are going to have 3y, which then that becomes equation number 3. Or you can even write it as equation number 1. No one will mark you wrong by having that as equation number 1. So from there, you can then eliminate equation D. Let's eliminate D. How are we going to eliminate D? By using Martinez by elimination or by subtraction. So you say equation number 3 minus equation number 2, of which simply tells you that you're going to subtract 3A and A. 3A minus A, it gives you an answer of what? Of 2A. And then 9D minus 9D, it gives you an answer of 0. Therefore, D is eliminated. So that's why it's called elimination, because it eliminates some terms. So here we eliminated D, which is equal to 6x minus 8x. So you just subtract 6 and 8, which gives you negative 2x. And then 3y minus 2y. So it's the same as saying 3 minus negative 2, which gives you positive 5 what? Positive 5y. Are we all together?
Mm-hmm.
Okay, then from there, you divide both sides by 2 to make A the sum of the formula, so that you obtain A, which is equal to negative 2 can divide here, and you will leave left with negative x, and there you're going to be left with 5 over 2 y. And that is what we are looking for in this question. We wanted to get the what? The first term, and first term is indicated by A. So you would have answered the first question if you have done something like that. Any question if you have with regard to what we have done on that question? Okay, it seems as we are all fine. Can we go to the next question, of which I would want you to try it first before I do it myself? Will that be okay?
Uh-huh.
Okay, actually is the question I gave you, but I would want to rewrite it on the board. So this is the question. So we have first 24 terms of an arithmetic series. So these terms are given as 35, 42, 49, and then the last term is 9, 196. So now the question requires us to calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7. So the last statement of this question is very, very important. So we are looking for the terms which are not what? Which are not divisible by what? By 7. Yes, and those terms, they must be in between the first term up to the last term of the sequence. So try to do this question before I help you out. I'm giving you 5 minutes to do the question. So now is your time to do that question. So if you manage to get it, let me know. Okay, the 5 minutes is up. Were you getting something? Must I do the question with you on the board? Hello, guys. Okay, let me do the question with you on the board. Now, let's read the question carefully because you can only answer the question after understanding what you are given there. So we are given that the first 24 terms of an arithmetic series, which is given here, the first 24 of the arithmetic, 24 terms of the arithmetic series are these ones which are given here. It's from 35 up to what? Up to 196. So now the question requires us to calculate the sum of all natural numbers from 35 up to what? Up to 195. So in other words, we are going to calculate the sum of 35 plus 36 plus 37 plus 38 plus dot dot up to what? 196. But now take note of this, that these terms must not be what? Must not be divisible by 7. So the terms which are here, they must not be divisible by 7. Okay, let me extend this series and you tell me the terms which are divisible by 7. So it's 35 plus 36 plus 37 plus 38, 39, 40, 41, 42. I'm not going to write all the terms because we can't finish all of them. There are too many. So now tell me from these terms, which ones are divisible by 7? Just tell me all of them which are divisible by 7. Let's start with the first one. Is the first term divisible by 7?
Yes.
Is divisible by 7. Therefore, this must be out. Can you tell me the second term which is divisible by 7?
The second term, no, it's not. 42.
42 is divisible by 7. And then the other term after 42, which can be divisible by 7?
Isn't it 49?
49. Did you see that the terms you are getting are from the series you are given up there?
Yes.
So it means all the terms from this series, they are divisible by 7. And those are the terms we're supposed to exclude from this series. So that is your task. You get the sum of this series and then you exclude the sum of the series you have up there. So now let's do and see how you can get to that. Definitely, the only way you can be able to get to the correct answer is by using the formula I gave you, which is for arithmetic series. So this is the formula that will help you to get to the answer. So now, how many terms do we have from 35 up to 196? We want to get the sum of all the terms we have here, including the ones which are divisible by 7. So how many terms do we have in total from 35 up to 197?
161.
16. Remember, we are including this one, eh?
Yes.
How many are they from 35 up to 196? Is it 161 or 162?
It's 161.
161, okay. We are excluding 34 terms from 196. Let me just verify. 196 minus 34.
34, 35.
Minus 34. Because this 35 term we are including it, né? It's part of the terms we are dealing with. Yes. So it's minus 34. So the 35th term is included in this case. Wait. Yes, it's included. 35th term is included. It's part of what you are dealing with here. It's part of the natural numbers from 35 up to 196. So you have 162, which is equal to n is 162. The total number of 10 from 35 up to 196 is 162 divided by 2 into 2. And then the first term of that sequence is 35. And then 162 minus 1. The D of this sequence. Can you tell me the common difference of this sequence?
One.
It's 1. Yes, definitely. and then put this into your calculator. Just substitute this as it is from your calculator and tell me the answer you get. Okay. We are going to log into the new meeting because this one is going to end just now. Let's just wait for the meeting to end and then we join to the same link. So, but in the meantime, if you have the answer for this, you can tell me.
Isn't it 18711?
18711. Okay. So now this is the sum of all the terms from 35 up to